But around them, there's a lot of civil engineering which you may not be aware. And sometimes when they come back, the teacher say, you forgot, underneath the ground, there's also structures there that civil engineers are responsible for. And that then they start to reflect on their role as a civil engineer. So there are a lot of different ways that you could do to get students to reflect, and project work is just one way.
Also, another reflect also, we ask the student, like after teaching all these things, we ask them to write journals, how you reflect on the certain topics. This is also another way, in journal writings. So they keep a journal and they reflect every time. I mean, like Helen said, there are many ways. Okay, in these ways they reflect on, like especially say, although I put under skill like sketching and CAD, but they have to reflect how to use it. If they draw this, are people going to understand, especially in drawing, engineering drawing? Okay. Any more questions?
Yes. As Dr. Amki mentioned, that you're going to mean that the defect is attitude.
Attitude, yeah.
Defect is attitude.
Reflect? No. Reflect is not attitude. No, it's not. Reflection is what you have learned. You reflect back. So it's different. Attitude is, I test the student attitude on the way he behave in class, the contribution.
Yes.
Mainly this.
So,
and whether they absent themselves all the time.
yeah.
Also one of my components.
So how you relate the defect again?
Sure.
In the case of defect, how
No, reflect is different. Attitude is different. Attitude is you're looking at the student's behavior. Attitude. Reflection is different really. Like what Helen say, you send the student out, you look at things, and then you reflect.
I think that many things that you can get your students to reflect on, it really depends on what you want to achieve in terms of outcomes. Okay, but reflection to me, in a sense, gets the student to think about their own thinking. What we call metacognition. That's one other aspect of reflection. So how did I approach this problem? How do I solve this problem? Okay, that is a reflection as well, getting them to think. Is that the best way? Has someone else done it better? Maybe next time I should not do this, I should approach it this other way. So it's really, to me, reflection is really thinking about your own thinking of how you approach certain issues. Yeah, that's to me. So it depends on what you want to achieve at the end of it. Yeah.
Could you give us like few tools?
Yes, I think.
That we can access the
Okay. So for us, when I do metacognition, which is to me reflection, the first thing I would get is to give students maybe an experience where they build or they solve something, and then ask themselves, how did they do it? Okay, so they will understand, they will say, okay, I did step one, I did this, step two, I did this, and it becomes a heuristic, a process that they go through. And then they can share between themselves, two students, or within a group. This is what I did, this is what you did. And maybe yours is better than mine. Okay, and then I come in as the faculty or the facilitator and say, hey, maybe both of you forgot a certain step, and so forth. And next time, perhaps we could all do it better. The extension of that is then to give them a second situation where now they're applying all this new knowledge, all these new processes to this second extension, to this second situation. So it really depends on what you want them to achieve at the end of that reflection. What is it you want them to reflect on and about? Yeah?
Another simple way, which we use quite commonly, you teach the students, say, certain topics. At the end of, say, 1 week or 2 weeks, you ask them to reflect what they have done. That is another reflection, because there's no specific formula. Okay, so one of the things that we ask them to do is reflect what you have done. Okay, how do you apply it? Reflect on it. It can be
Something
has,
like
it can,
respond to the
yes,
knowledge.
yes. That means it reflect what they do, then they will know what they have learned, whether they have understood. This is the simplest form of reflection. But the way I use it here is different. I teach you mechanics. Now you think that by gravity, if the car is heavy, it's going to come down fast, right? But it didn't happen. So what happened? You learn that gravity, if heavier it is, it's not true, right? Actually, gravity, whether it's heavy or light, the speed is always the same. It's different because of the gravity. So these are the things you got to reflect. Why it didn't happen? I use it in a different way. Okay? Any more questions? Okay, if not, I will go on to workspace. I'm bringing tomorrow topic forward. Okay, workspace is standard 6. Okay, now workspace is a very one of the important standards. In Singapore, I would say, I think from here I look at University of Chulalongkorn, I don't think you have workspace problem because you have a lot of land. And but in other countries like Europe, I visited KTH, and they told me that they actually have to rent the space. So for them to have big workshop is a luxury. And when I visited them, I thought that because they were one of the first, to initiate CDIO, I was expecting to see a lot of labs. So when I went there, I was quite shocked. There was only one big lab, and all the discipline, all the engineering actually used the one big lab. Then when I came back to Singapore, I thought, hey, we are very lucky, we have many, many labs. Okay, so what are the workspace used for? For students to engage in their learning, for the C, for the conceive, for the design, for implementing, for making models. So basically workspace is an important learning space, or you can call it learning space for students to learn. So I want to share with you some of the examples that we at Singapore Polytechnic have. But before I do that, let's look at MIT. They call it the learning lab. Okay, and if you look at the internet, if you do a search, you can read about it. And they use it for disciplinary knowledge, the knowledge discovery, system building, community building. Now in Singapore Poly, we have, this lab is actually under my jurisdiction. We built this a few years ago. I call it the Integrated Project Center. Now if you look at each cubicle, okay, you got the PowerPoint. If you look at each cubicle, can you tell me something about it? This is used for two purposes. Make a guess. Can you tell me something about the lab? It's very colorful. But what else? Look at it carefully and tell me what you see at the top. Do you notice something? You notice that they are, you notice this one? Okay, when I first built this lab, okay, this is for the 5+1. That means we have students, ours is a 3 years course, 6 semester. But I have two groups of students. One is doing real industrial projects. So we call it the 5+1 model. That means the student finish all the curriculum in 5 semester. And then the last semester, they do nothing but projects, okay? Now, why do we do that? Because we are doing industrial projects. Now, when you do industrial projects, when the industry comes to you, you cannot tell them, wait, my students are not ready. So that's the reason why we introduce this 5+1, so that every half a year, we are ready for industry. Because if you want to take on industry projects, you got to be ready all the time, okay? So one of them is to build industrial, machineries. Every year we get a lot of projects for students to do. And the industry are aware that if there's any mistake, sometimes the losses is very high, but they are aware of that, okay, that they're designed by staff, but actually done by students. Now this is another group of students who do CIE, stand for Creativity, Innovation, and Enterprise. Okay, now this is a very special project because it is a multidisciplinary project between the School of Mechanical Engineering and Chemical Engineering. So if you look at the students there, they're actually two group of students. Actually, electrical was supposed to join, but in the end, no students came on board. So you look at all these students, they actually combined, they're all from two schools. And if you notice at the top here, So because the last word is enterprise, correct? So the students group themselves and they're given each cubicle for about half a year, 4 months to 6 months. And they name their own company. If you look here, this is their company names. They design their own logo and the projects, some of them are from university, some from industry. So they actually work together. So this place is good for C&D, conceive and design. Okay? Now, besides using this, the lab is also, because all the cubicle that you see here, they're numbers and they can actually reconfigurable. You can actually change them. And you see the next slide. Okay, this is what they're at work. And you see the next one. Okay, so it's used for other purpose. We have a multidisciplinary projects between this is one between a few schools. So you can see the students very active, sitting around there doing C&D. Okay, and also we have critic session. After they've conceived, there's a critic going on, and after that, after conceiving, they will design the products. And we also have a workspace, the model making workshop, where they make their model. So this is for the I, implement. And then the operates, you see just now the challenge, just operate. Okay, so it covers basically CDIO. Okay, and operates. Now, so when you want to do your CDIO activities, one of the things that you have looked at, not only the skill set, okay, but you must also look at your workspace. How are you going to support all these activities? So I have some pointers here. You look at the layout. Your layout got to be flexible. Okay, what we see here just now, this is another workshop. You see, the layout, you see how the students, it can be reconfigurable, the table, and this very same room is also used for exhibition. Whenever there's a major exhibition, we put all the cubicle aside. Okay? Whenever there's a major exhibition, what we do is that we shift all this to the side, and the whole space is empty for exhibition. Okay, so it's not fixed. So when you design the space, it's good to consider all this. Okay? Okay, you look at the pointers. So layout is very important. I will show you more examples after this. Then visualization as well. Now, in the poly, most of the room we have now, on the wall, we built white walls. So that means you can scribble, and then you can erase. So this is another form of visualization. And the last point is on information management. Recording of information, we ask students to use, for our CIE projects, we actually have a database, or we call to store the students' data, and also allow the student to communicate. Okay, these are some of the things. So the student can actually communicate via a database system. Okay, so more examples on the layout. You can see here how the layout. This is in other schools. This is in EEE, right? Which one? This one? These are all in his department, Lee Chi-Wai's department. I think he's going to show you more, right? Chi-Wai? Okay. I can't remember. I mean, you can't remember your own lab? Okay, visualization support. You see all this board, the cubicle, the student can also write on it. So when they design something, we took a long time to design this. We actually got in a designer from outside to help us as well. We give them a specification. So that means it's not only a cubicle. Okay, all the tables you see here, it can be configurable, and then the student can write on the board, they can paste on the board. So these are the things you have to consider. Okay, look at more. These artifacts. Okay, and I'll show you the model, and we have also a lot of workshops all over Poly for students to fabricate their parts. And also this morning, Chi-Wai shared the Fab Lab, isn't it? Also for students to do their work, the I and O. Okay, implementation operates. Okay, I just thought we put some lesson drawn when we were doing what are the things we actually have to consider. Okay, we have to trade off between specialized equipment and workspace flexibility. Now, if you have specialized equipment, normally you cannot move. Let's say you have a molding machine. You can't move the molding machine. So how? but you want a flexible workspace. So in the lab, just now the lab I show you, we have actually, because we use pneumatics, we have PowerPoint. Instead of fixing it onto the ground, we actually fix on top. Electrical power, everything is on the ceiling. So that means to give you a big room. That's why the room, you can take out all the furniture and you can use it for projects. Okay, these are the things you have to consider. Yeah, the PowerPoint is hanging up from the ceiling. Even the pneumatics point, for pneumatics to run pneumatics, also hanging from the ceiling. So these are some of the things we consider. Okay, so to allow you to have flexible space. And also another problem we face, project artifact size and how to store them. We have a very major problem. At the end of the year, when students finish the projects, we always can't find space to store. So what happened? One of my staff is very ingenious. There's an empty space outside the workshop. Nobody uses it. So he actually suggested, it doesn't come from a lecturer, no. It came from one of the support staff. He says, this space is empty. Why don't we convert it? So it's now converted. So they built it up, and that's where we store all the students' projects. So it doesn't mean that when you store student project, it got to be in the building. Okay? So he found this empty space, and we just asked for budget, we build it up, and we store the projects. So this is a major issue. So normally we now advise students in the final years project, when you build the projects, we try to ask them to constrain of the size, because some of them build project which is very huge. So we tell them try to constrain it. Okay, so these are the things you have to consider. Okay, so I thought I'd just bring up these 2 points to highlight to you. Okay, any questions? Yes.
For this innovation as well, and also goes back to your
Mm.
where does the money come from?
Oh, where does the money come from? It's a very good question. Okay. Every time I present this, people always ask me this question. Okay, now, we have, for each department, let's say, for example, when I was the deputy director of the schools, we were given a 5 years plan. So we actually plan out, in the 5 years, what are the things we need. We give a budget. Then after we submit this, the ministry will give us money. From there, we actually got the plan. But for CDIO, what happened was that the program come in very fast. So where does the budget come from? So we try to squeeze, like maybe spend less on one thing, and because the budget is already fixed, unless there's surplus budget. So I'm like a scavenger, in my school, whenever there's surplus budget, I'll say I need it. So if you don't plan for it, then you have to wait for surplus, or maybe sometimes windfall.
You said those key courses to
Those are budgeted for already.
is to open for the projects from the industry.
Yes.
Even for your guests, I'm sure the industry contribute something to that.
Yes, okay. Industry contribution is a different thing. For every projects, let's say for my school, I don't know about electrical, for my school, mechanical, aeronautical, we got about 20 to 30% of our projects sponsored by industry. So the industry actually pay for the projects. That means, yes. So they are the one, no, we got to knock at every door, and then, this is different, this is CIE, in the normal student projects, but for our industrial projects, the teaching factory projects is different. We actually went to look for real projects. That means industry give us projects, they pay us money to fabricate, but we don't let the student do the C&D. The C&D are done by staff, and I have designer who am employed from industry. So they do the C&D, but part of the D they let student do for the final years projects. But when it comes to I and O, when it comes to fabrication, we normally go out, ask factory to do it because it's more reliable. But certain parts we ask students to do. But when it comes to the O part, the student actually commission and put everything together. And they are the one who actually went to industry to teach them on how to operate. But this is the very big projects. But talking about the CIE projects, those are smaller scales. Smaller scale normally is a few $1,000s. So industry will give the money to the student to build the projects. About 20 to 30%. I don't know about yours. How many percent is yours? Industrial projects. Is it higher percentage?
Actually, in Singapore, Poly, we have quite a lot of sources for funding.
No, he's asking about industry.
Even industry also got different levels.
Yeah.
some up to 3,000